All right, we're going to go over nonlinear relationships. Okay, there's a couple important definitions you have to know in order to understand nonlinear relationships, especially when we're putting them onto a graph. Now, you technically should have went over this in grade 9. And we talk about certain types of variables. When we are comparing things on a graph, we have two types of variables. One that we represent on the x-axis and one we represent on the y. The names of them are the independent and dependent variables. The independent variable is, from the definition, this is a variable that you control before the trial or test. And the dependent variable, this is the variable that you measure during the trial or test. Okay, so what does that actually mean? One way to think of it is the dependent variable changes depending on the independent variable. In other words, it's dependent on this variable. Now, we always represent the independent variable for uniformity on the x-axis. Okay? So our x values, or whatever variable is measured by the x, that's the independent variable in a study. And the dependent variable is measured on the y-axis. Okay? We measure it with those. So, what we're going to practice doing here is we're going to go through a couple examples. I'll just highlight these so that they're similar to what we've done. Independent is x, and dependent is on our y. We're going to go through a couple examples and try to define whether it is independent or dependent. So, we have 4 examples here. I want you to think about these before you blurt out an answer. We have 2 variables, one being time and the other being height. So, we don't exactly know what they're referring to. We'll take an assumption. Maybe it's like the height of a person as they grow. Okay? We got to figure out which one's independent and which is dependent. So, let's think of it. I'm going to think of it in the reverse way. So, I'm trying to give you the answer. But, is time dependent on height? So, the taller I get as a human being, does that speed or slow down time? No. As time passes, is that speed or is that increase or decrease height?
Yes.
Yeah, right? It depends. I could say as you get older, you decrease height, but for the most part, people grow from the ages 0 to 18. They grow taller as time passes, okay? In fact, anytime, almost 99% of the time, time will be the independent variable, okay? That will be the one we put on the x-axis, and height will go on the y-axis, okay? Let's think of another one. This one's a little more sports-related. Shots on goal versus the amount of goals you get. Which would be considered the independent variable? Which would be the dependent, Michael?
Shots on goal is the independent.
Why is that?
Because shots on goal depends on how many goals. Basically.
Goals depend on your shots on goals, right? So in other words, you can't score a goal unless you take a shot. And maybe the more shots we take, the more goals we end up scoring. So the shots on goal would be the independent variable. And the dependent variable would be our goals. Okay. Here's another one: speed versus time. Now, Malik, what do you think?
Time is the independent variable.
Yeah, that's right. Say it's driving a car. Our time is most likely our independent variable, and speed the dependent. Now, technically, in theory, when you get towards the speed of light, time changes, but we're not going to really talk about that with speed. Just imagine you're driving a car, right? Maybe we speed up as more time passes because our foot has the pedal to the ground, or maybe we're putting our foot on the brake and we're slowing down as time passes. But time being independent on the x-axis, speed y on the y-axis. And finally, height thrown, that word's supposed to have an N at the end of it, height thrown versus bounce height. So maybe we throw a ball from somewhere. Which is independent, which is dependent? Anyone else? So, Mal, go again.
Bounce height is independent.
Is independent? Why would that be independent?
Because it matters on how high you throw the ball.
So it doesn't matter where I throw the ball from, the bounce height will affect it. So as a ball bounces, my height where I throw it from changes.
Other way around.
Other way around? Everett, what would you say?
It's independent because the bounce depends on how high you throw the ball.
Yeah, that's right, right? If I drop it from a building and it's a very bouncy ball, it's probably going to bounce very high. Or if I just drop it from my waist, it won't bounce that high, right? So the height thrown is the independent variable, and our bounce height is our dependent variable, okay? So those are some definitions you need to know when graphing anything. We're talking about independent and dependent variables. Now we're going to talk about linear and nonlinear. I want you to focus on these. Linear makes what shape on the graph? Straight line. Okay? So let's look at the very first example here. What type of relationship does this scatter plot probably have?
Positive.
Positive what?
Linear.
Yeah, positive linear or nonlinear?
Linear.
Linear, right? Our line of best fit pretty much forms a straight line. And you're right, the slope of this is positive. This is our linear relationship. Okay? I'm going to estimate a curve of best fit here, or a line of best fit. Does that look linear? No. So we're going to classify it as nonlinear. Okay? This is a curve of best fit. We're going to come back to this because this one's actually very important for what we're doing next. Let's drop to another. How about our third example here? Linear or nonlinear? Why is that? Right. It looks like it comes down and then curves. In fact, this is also known, this is nonlinear. It's probably an exponential relationship, but we'll deal with that later in math. We don't need to do it right now. And what about our last one? Yeah. Linear, what slope? Negative. Great. Okay, now I want to talk to you just briefly. Our second example there, this is actually what we're about to really start delving into. We're going to be talking about, this shape is called the parabola. Okay? And the parabola comes from a quadratic equation. Okay? This is the shape quadratic equations make on a graph. It looks almost like a U shape. The formula or the equation is usually some form of y equals x squared. Remember, we're doing FOIL and factoring. We were dealing with x to the power of 2. We were manipulating quadratic equations. That's what we were going over. Okay? Now, technically, this one's facing upside down, so really this one is actually y equals negative x and some form of that. But really, I just want you to get the idea that this is a quadratic relationship, and we are going to be really going into that type of information in the next little bit. Okay?